let's look at some application problems now that we've got the idea down. So we have the mean incubation time for a type of fertilized egg kept at 100.4 degrees Fahrenheit is 22 days. Suppose that the incubation times are approximately normally distributed with a standard deviation of 2 days. So keywords in here is approximately normally distributed, so we need that to be able to calculate our probability. And it tells us our mean and our standard deviation. So those are key things that we're looking for in the problem. So let's go ahead and write down what we have so far. So we have that our mean is 22 days and our standard deviation is 2. And we have approximately normally distributed, or even with our problem. So part A, we want to know what is the probability that a randomly selected fertilized egg hatches in less than 18 days. So we're looking for the probability that X, and now we're working with X, is less than 18. That's what we're looking for. Right, so again, we could draw in our curve here. So in the middle we have 22. And I'm going to put an X because we're working with X now, because we're not working with the standard normal distribution curve, but just a normal curve. And then our standard deviation is 2. So if I go up 3 standard deviations, so 22 plus 2 is 24, plus another 2 is 26, plus another 2 is 28. And if we go down 3, 22 minus 22 minus 2 is 20, minus 2 is 18, minus 2 is 16. We're looking at less than 18. So we're looking at this region here. So if we think about empirical rule, this was before what, 2.35, and this was 0.15. We know this should be approximately 2.5, somewhere in that ballpark if we kind of think about that, and that'll let us know whether we've did something right or we're on the wrong track here. So let's go to StatCrunch here. So our mean is 22. Our standard deviation is 2, and we want the probability that X is less than or equal to 18, and we're looking for that area or the probability of that answer. So we're going to type in our values here. So our mean is 22, our standard deviation is 2, and we're looking for the probability that X is less than or equal to 18, and we're going to hit compute. So our answer here is approximately 0.0228. So you'll see that's close to 0.025, which is what we anticipated there. So let's look at the next part. So our mean is still 22, standard deviation is 2, and we still have approximately normally distributed. So here we want to know what's the probability that a randomly selected fertilized egg takes over 26 days to hatch. So we want the probability that X is now greater than 26. Right? So again, rough sketch here. So our mean, and go up by 2, since that's our standard deviation, and then down by 2s. Right, and we're looking for greater than 26. So we should get about the same answer, right? So our mean and standard deviation are the same. We're going to change this to greater than 26. So we should know we get the same answer since it's symmetric. And we do. So this is approximately 0.0228. There. our next part here. We want to know the probability that a randomly selected fertilized egg hatches between 20 and 22 days. So again, our mean is 22. Our standard deviation is 2. And we're looking for the probability that it's between 20 and 22. It's our rough sketch here. So our mean is at 22, and then we go up by 2's. And down by 2's. And we're looking for between 20 and 22. So if we remember with empirical rule, this is about 34%, so we should get approximately 0.34 or something close to that when we calculate this on StatCrunch. So our mean is still 22, standard deviation is still 2, and we're going to go to between. You'll notice this copy over, so let's change these values here. So this is 20, and this one is 22, and we'll hit compute. And notice we get 0.3413, so that's pretty close to our 34% from empirical rule. So remember the empirical rule, it says approximately, right? So it gives us a rough gauge when we have values that are similar to what we're working with on empirical rule. So one more part here. We want to know, would it be unusual for an egg to hatch in less than 19 days? So we're looking at the probability that X is less than 19. Let's draw on our curve again here. And X. And our mean, oops, let's not put that there. Our mean is 22, standard deviation is 2. So 22 go up by 2's. And then down by 2's. Notice this isn't one of the empirical rule values. It's okay, so 19 is in between here. We want less than 19, so we know it should be a little bit greater than 0.025. Right? So we're going to calculate that. So let's go to standard. And 22 is our mean, 2 is our standard deviation. We want X is less than or equal to 19. And we're going to hit compute here. And we get approximately 0.0668. Okay. So would it be unusual for an egg to hatch in less than 19 days? So no, it would not be unusual because probability that X is less than 19 is greater than, and our magic number here is 0.05, right?